Have you ever stared up at a night sky and wondered what is actually up there, beyond the stars? Right now, more than 36,000 massive objects are silently circling our planet. This hidden danger is completely invisible to us, yet it threatens everything we rely on. Stay with me because I am about to reveal the strangest things orbiting Earth. October 4, 1957. That single date didn't just launch a satellite. It launched an entire era of humanity's presence beyond our atmosphere, and it also created the very first piece of space junk. This was Sputnik 1, a polished metal sphere just over half a meter wide, sent into orbit by the Soviet Union. It was a stunning achievement, a technological marvel that captured the world's attention as it beeped its way across the night sky. But think about that for a second. The moment it fulfilled its mission, the moment its batteries died, it didn't disappear. It became a lifeless husk, an inert piece of metal circling the Earth, the first artificial object to become permanent debris. Before that night, the space above our planet was pristine, a silent, empty void. With one launch, we introduced the concept of a junkyard to the cosmos, a place where our discarded machines would outlive their purpose by decades. This is the origin of orbital debris, a term that sounds technical but is simply a polite way of saying our garbage in space. It's any human-made object in orbit that no longer serves a useful function, from a defunct satellite the size of a bus to a tiny fleck of paint. But no one thought about that in the stillness of 1957. The focus was on the triumph of getting there, not on the consequence of leaving something behind. The story of that first satellite, documented by the NASA History Office, marks the precise moment our relationship with the space above us changed forever. We opened the door to the cosmos, and we didn't even notice we had also opened the door to a dump. So, if one small sphere was all it took to start this, what does that say about the mountain of things we've sent up since? Imagine a giant metallic balloon the size of a 30-story building, silently drifting through the night sky and reflecting sunlight so brightly that it outshone every star in the sky. That was Echo 1, a NASA experiment launched back in 1960, and it was one of the strangest things humanity ever put into orbit. The satellite was essentially a hollow metal sphere measuring 30 meters across, made of material so thin it could be crumpled up in a suitcase. It wasn't built for communication or observation. It was built to bounce radio signals across continents, a passive mirror in space that changed how we thought about global connections. Its surface was so reflective that it became one of the brightest objects in the night sky, visible to anyone who knew where to look. But here's the twist, that gleaming balloon was also one of the first pieces of intentional space junk, a shiny relic abandoned after its short mission ended. And while that balloon was a marvel of its time, the strangest satellite today isn't shiny or metallic at all, because it's made of wood. In March 2024, researchers from Kyoto University teamed up with a Japanese forestry company to launch LignoSat, the world's first wooden satellite, into orbit. Yes, a satellite made of wood, designed from magnolia trees and built to test whether natural materials can survive the brutal conditions of space. The idea sounds absurd, but the logic is actually brilliant. When wooden satellites re-enter the atmosphere, they burn up completely without leaving behind harmful metal particles. That means no toxic debris raining down on our heads, just clean ash that vanishes into the sky. So we have a giant metal balloon from the 60s and a wooden box from the future. Two objects that could not be more different. But they share one thing. They both made us question what belongs in space, and what we're willing to throw up there. If we've launched a balloon and a piece of wood, what other bizarre things are silently orbiting above us right now? Imagine a ghost drifting 800 kilometers above your head, 26,000 feet of dead metal heavier than a city bus, moving at 17,000 miles per hour. This is not a metaphor. It is ENVSAT, once Europe's greatest eye on Earth, now the largest piece of space junk ever left to roam unchecked. For over a decade, it has been silent, uncontrolled, and utterly unguided, a tombstone orbiting a planet that forgot how to bury it. In 2002, the European Space Agency launched ENVSAT with pride. An 8-ton marvel designed to watch glaciers melt, oceans warm, and forests vanish. It was the size of a double-decker bus, wrapped in a golden solar panel the length of a tennis court. For 10 flawless years, it sent back data that reshaped climate science, and scientists trusted it like a heartbeat. Then on April 8, 2012, the signal simply stopped mid-sentence. No warning, no farewell. Just static where a voice used to be. Engineers spent months trying to wake it, sending command after command into the void, but ENVSAT refused to answer. It became a corpse in orbit, and here is what makes it horrifying. They cannot move it, cannot steer it, and cannot even track it perfectly. The ESA has admitted that this 8-ton monster has no working thrusters and no way to avoid a collision. It tumbles slowly through the most crowded highway in space, where hundreds of active satellites fly daily, and nobody can tell it to get out of the way. What does that mean in practice? Picture a bus-sized object hurling through a neighborhood of small cars with no driver, no brakes, and no lights. The European Space Agency now spends millions each year just to predict where it will be, because one wrong calculation could turn a working satellite into a cloud of shrapnel. They call this the greatest single collision risk in low Earth orbit, and they are not exaggerating. It has already forced multiple maneuvers by other spacecraft just to stay alive. The truly chilling part is not its size or its silence. It is that Envisat is not alone. Somewhere up there, hidden from the naked eye, there are hundreds of dead Titans just like it, abandoned after their missions ended, still circling the Earth with no one at the helm. And every single one of them is a loaded gun, waiting for the wrong moment to fire. How many more of these metal ghosts will we leave drifting above our heads before one of them finally takes aim at us? February 10, 2009 started like any other day for the satellites orbiting above us. Two machines built by rival nations were silently tracing their paths around the Earth. Nobody expected these two pieces of hardware to find each other in the vastness of space. The first was Iridium 33, an American communications satellite that had been working for over a decade. The second was Cosmos 2251, a defunct Russian military craft that had been dead in the water since 1995. They were on a collision course, moving towards each other at a combined speed of over 42,000 kilometers per hour. At 1656 UDM, they met. The impact was so violent that both satellites were instantly destroyed, shattering into thousands of pieces. According to the NASA Orbital Debris Program Office, this single event scattered more than 2,300 trackable fragments across low Earth orbit. It was the first time in human history that two fully intact satellites had collided. Why is this moment so significant? Because it wasn't an accident in the traditional sense. It was a forecast of what space was becoming. For decades, we assumed that space was so vast that collision was nearly impossible, but the math proved us wrong. These two pieces of metal turned a theoretical risk into a very real event. You can actually check this for yourself, which is both fascinating and terrifying. Public databases like those maintained by the US Space Surveillance Network log every known object, charting the same orbits where our modern satellites now fly. Just search for Iridium 33 and you will see an entire cloud of debris tracing a ghostly ring around our planet. That cloud now serves as a permanent obstacle course for every new rocket we launch. Every single one of those 300 fragments travels fast enough to damage or destroy an operational satellite on impact. The aftermath of that 10-second crash has become a long-term problem that we will manage for decades. So the next time you hear about a close call in orbit, remember this. It wasn't a natural phenomenon that started the chaos. It was us, and the wreckage is still out there, circling silently. The countdown for the next inevitable strike has already begun, and it's only getting louder. Every satellite ever launched came with a price tag that would make most people choke on their coffee. But here is the twist that flips the entire industry on its head. That price tag has collapsed by 90% since 2010, according to Space News, dropping from roughly $20,000 per kilogram to just about $2,000. This dramatic plunge has triggered a launch frenzy, putting more metal into orbit than ever before in human history. Now, with thousands of dead husks circling above us, a new kind of entrepreneur is looking up and seeing something entirely different from a disaster. They are seeing a fortune waiting to be collected, and the numbers behind this emerging gold rush are genuinely staggering. The global market for cleaning up orbital garbage is projected to hit $1.1 billion by the year 2028, a massive leap from its modest $200 million valuation just a few years ago in 2022. Grandview Research and Allied Market Research both back this explosive growth, signaling that governments and private companies are finally willing to pay serious money for a cleaner sky. But who exactly is cashing in on this cosmic mess? And what does the actual business of trash collection look like when the trash is traveling at 17,000 miles per hour? The answer involves a Japanese company that has decided to turn space junk into a profitable enterprise, and their methods are as clever as they are ambitious. Astroscale, a firm born in Japan, has already pulled off the first commercially viable debris removal mission in history, proving that the technology to capture and deorbit dead satellites actually works in the real world. Their approach involves sending a chase vehicle into orbit that locks onto a defunct satellite, grabs hold of it with remarkable precision, and then guides the entire package down into the atmosphere where both burn up harmlessly. JAXA, Japan's space agency, has partnered closely with them, lending credibility and technical muscle to an operation that once sounded like pure science fiction. The successful demonstration in 2022 sent shockwaves through the aerospace industry, because it showed that what was once considered impossible is now just another engineering problem with a price tag attached. So why does any of this matter to you, sitting safely on the ground, when the real action is happening hundreds of miles above your head? The economics of space have shifted so dramatically that what used to be an exclusive club for superpowers is now a crowded highway with traffic jams and fender benders. When launching a satellite becomes cheap enough for universities and startups, the sky fills up fast. And with that growth comes a proportional increase in broken, abandoned hardware. The clever part of this new economy is that the very same rocket technology that created the problem is now enabling the solution, and entrepreneurs are exploiting that irony for profit. The business model Astroscale is perfecting works like a tow truck service for the heavens. Except the clients are insurance companies and satellite operators who desperately want to avoid catastrophic collisions. Each successful capture mission builds a reputation and a database of techniques that make the next job cheaper and more reliable, creating a powerful cycle. It is a classic market story where scarcity creates value, and right now there is no shortage of debris to practice on. Every dead satellite weighing several tons represents a potential payday, and that realization is dawning on venture capitalists, who previously would have laughed at the idea of investing in space garbage collection. By 2028, analysts predict this sector alone will be worth over $1 billion, and that estimate might actually be conservative given how quickly the debris field is expanding. When you consider that more than 36,000 tracked objects are currently swirling above us, with millions of smaller fragments that could shred a spacecraft in an instant, the demand for cleanup services becomes crystal clear. The companies that figure out how to do this safely and affordably will control a market that has nowhere to go but up, because the problem is only getting worse each year. So while the rest of us stare at the sky with vague unease, a handful of bold engineers are rubbing their hands together, because they have figured out the ultimate secret. Space junk, once the ultimate symbol of human carelessness, has quietly transformed into the most unlikely goldmine of the 21st century. Look up on a clear night, and you might see more than stars. You might be watching thousands of machines blink in unison, a network so vast it encircles the entire planet. Starlink, the brainchild of Elon Musk's SpaceX, now operates over 6,000 active satellites as of 2024, which is roughly 60% of every functioning satellite currently in orbit, according to reports from Reuters. This isn't a slow creep into the heavens, it's an industrial takeover happening at a pace that leaves regulators and astronomers scrambling to keep up. Each of these units weighs about 260 kilograms, and their design lifetime is a mere 5 years, as detailed in filings with the Federal Communications Commission. When that short life ends, they will either burn up in the atmosphere or become just another piece of dead metal circling our world. The sheer speed of deployment is staggering if you pause to compare it with history, because the total number of active satellites in all of the previous 6 decades combined was once dwarfed by what one company has launched in just a few short years. You don't need expensive equipment to see this constellation for yourself, because on a dark night, roughly an hour after sunset, you can often spot them with your naked eye as a string of bright lights moving steadily across the sky like a celestial train. Think about that for a moment, since the night sky is no longer a static map of ancient stars but a busy highway with new traffic appearing every single week. The dominance of this single corporation isn't just a business story. It's a fundamental shift in who gets to control the view from your own backyard, and the implications of that shift are only just beginning to surface. There is a kind of quiet grief that settles in when you realize the night sky you grew up with is slowly being erased, not by clouds but by our own ambition. We have flooded the darkness with light, and the stars are paying the price for our progress. According to Astronomy magazine and the International Astronomical Union in 2023, the brightness of the night sky has been increasing by roughly 10% every single year, a staggering shift driven by the sheer density of satellites now circling above us. This relentless glow is not just an aesthetic nuisance, it is actively blinding our most powerful tools for understanding the universe, a fact that feels almost too ironic to accept. Think about the Hubble Space Telescope, our window to the deepest corners of existence, and the researchers at the University of Michigan who made a disturbing discovery in 2023. They found that bright streaks created by Starlink satellites have appeared in 5% of all images captured by Hubble, corrupting the very data we rely on for groundbreaking science. That means 1 in 20 of the breathtaking photos and critical measurements we get from this iconic observatory now carries an artificial scar, a digital graffiti etched by our own machines. This is not a minor inconvenience for astronomers. It is a growing corruption of the purity of our view, a constant noise drowning out the faint whispers of distant galaxies and ancient supernovae. How do we claim to explore the cosmos when we are busy polluting the very window we look through? The The problem is compounded by the fact that this isn't just about professional observatories. It is a loss that is becoming personal for everyone who has ever looked up in wonder. One of the most profound consequences is how this artificial light is severing our connection to the natural world, making the constellations our ancestors navigated by feel like a distant, fading memory. This is where you can actually witness the problem yourself, because differentiating between a meteor and a piece of space junk is becoming a necessary skill for any skywatcher. When you see a streak of light, look for the color and the speed. A meteor typically burns bright and fast, vanishing in a flash of white or yellow, while a piece of debris tumbles slower, showing a steady, sometimes blinking reflection of the sun. The next time you spot a moving light that doesn't behave like a shooting star, you are not witnessing a cosmic event. You are watching the debris we have created. What we are experiencing is the slow, quiet suffocation of our observational capabilities, a tragedy that unfolds not in a single moment but over years of incremental loss. Every new satellite that joins the constellation only adds another line to the canvas, another brushstroke of artificial light that obscures the masterpiece behind it. We are building a monument to our own technological prowess, and in doing so, we are blindfolding ourselves at the very moment we need to see the farthest. This isn't just about the faint smear of the Milky Way becoming harder to find. It is about our collective ability to answer the most fundamental questions of our own existence. So, as the sky fills with our creations and the stars fade behind a veil of our making, one has to wonder, what will be left to discover in the heavens when we have finally succeeded in turning off the lights? There is no place to hide on the International Space Station. Imagine living in a metal can the size of a football field, hurtling around Earth at 17,000 miles per hour, while thousands of bullets try to hit you. That is the daily reality for the astronauts aboard the ISS. The station has to perform evasive maneuvers between 2 and 5 times every single year just to survive. Each one of those dodges burns roughly 1,000 kilograms of precious fuel. But in November of 2021, the danger became something far more real than a routine adjustment. The nightmare began when Russia destroyed its own defunct satellite, Cosmos 1408, with an anti-satellite missile. That single act of violence in space created over 1,500 pieces of trackable debris. The shrapnel didn't care about international borders or scientific cooperation. It just spread out, a silent field of speeding metal waiting for a target. And the target was the ISS with 7 astronauts on board, including crew members from the United States, Russia, and Japan. The crew had no time to admire the view. They were ordered to scramble into the Soyuz spacecraft docked to the station, a tiny lifeboat meant for escape. For more than 3 hours, they sat in their suits, strapped in and ready to bail out if the station took a hit. It was one of the longest emergency shelter-in-place procedures in the history of the orbital outpost. Can you feel the tension of sitting there, knowing a piece of debris the size of a fist could end everything in a flash? That debris cloud didn't just threaten the station that day. It became a permanent hazard. A lingering reminder that the orbit is not a playground. The station survived, but the incident proved just how fragile this human outpost truly is. The line between a routine day in space and a catastrophic disaster is thinner than most people realize. And the next piece of junk might not miss. Somewhere around 1978, a NASA scientist named Donald Kessler looked at the growing junk pile around our planet and asked a terrifying question. What if the orbit becomes so crowded that collisions trigger more collisions, creating a chain reaction that seals us inside a tomb of metal? His math said it was possible, and he published a warning that still haunts astrophysicists today. Picture 1,000 shards of metal racing at 17,000 miles per hour. When they smash into another satellite, they don't just dent it, they shatter it into a cloud of brand new projectiles. That's the Kessler Syndrome, a cascading cascade where one piece of debris turns into 100, and each of those pieces hunts for its next victim. Scientists ran a computer simulation in 2004, and the results were not comforting. Even if we launched no new rockets, the debris field would still grow exponentially because the fragments would keep colliding with each other. The sky wouldn't just be dirty, it would be actively hostile, and reaching space might become impossible for centuries. Now, in 2024, the European Space Agency confirmed that we're not in a hypothetical threat anymore. They've mapped over 500 debris clouds circling Earth, and at least 10 of them are dense enough to begin that self-sustaining chain reaction on their own. You aren't watching this on a screen, you're standing right beneath the storm, and it's only one wrong orbit away from starting. When you want to see for yourself how close these fragments get, there's a trick that takes less than a minute. Try a service like Heavens Above or the ESA's Orbital Tracking Database, and you can see live predictions of when a dead satellite will tumble back toward the atmosphere. It might feel like checking a ghost's schedule, but that ghost has a weight of 8 tons, and it's heading your way. So the next time you hear a siren outside, don't assume it's traffic. The real alarm has been ringing over our heads for 40 years, and the echo is only getting louder. Somewhere in Japan, a team of engineers is doing something that sounds like science fiction. They are reaching out from Earth to gently grab a dead satellite and drag it out of the sky. This is not a scene from a movie. It is the daily work of a company called Astroscale, and they are turning the space junk crisis into a business. After decades of warnings and collisions, the first real cleanup crew has finally arrived, and their mission is just beginning. The Japanese company Astroscale made history when it completed the world's first commercially viable debris removal mission, proving that we can actually catch and deorbit a defunct satellite. Working with JAXA, their technology successfully demonstrated the ability to rendezvous with a dead spacecraft, capture it, and steer it down to burn up in the atmosphere. It was a delicate dance in the vacuum of space, with magnets and precise thrusters instead of nets and ropes, and it worked flawlessly. For the first time, humanity has a proven method to clean up its own mess rather than just tracking it from the ground. But the story of accountability does not end in orbit, because in 2023, the US Federal Communications Commission issued a fine of $150,000 to the company Dish Network. The reason was simple. They failed to move an old satellite to a safe disposal orbit as they had promised. It was the first time a government agency had ever penalized a company for leaving space junk behind, setting a legal precedent that the sky is not a free dumping ground. This combination of new technology and new regulations is shaping a future where cleanup isn't just possible, it's mandatory. If you want to witness this new era with your own eyes, you just have to look up at the right time. The commercial satellites darting across the twilight sky, like the Starlink constellation, are easy to spot with the naked eye, appearing as a string of moving stars. And as the debris removal missions become more frequent, you might just catch a glimpse of a smaller chaser vehicle following closely behind a larger, tumbling target. So while the future of space travel seemed doomed by our own trash a few years ago, the tide is finally turning, and the first heroes of orbital cleanliness are already at work. Every single year, humanity buries itself under roughly 350 million tons of new waste, a figure that is almost incomprehensible until you realize our orbital backyard is just as messy. The World Bank tracks the ground problem, but NASA watches the sky, and there, the numbers get stranger. Low Earth orbit, the only area we can realistically use, represents just 2% of the space available, making it a uniquely crowded and finite resource. Within that thin shell, we are currently tracking about 36,500 pieces of debris larger than 10 centimeters, each one a potential bullet. However, the truly terrifying part is that fragments smaller than 1 centimeter could number over 130 million, and those we cannot even see coming. We treat space like an infinite dumpster, yet it is a tiny, fragile envelope around our planet, and we are filling it with our carelessness. Before humans ever launched a rocket, space had its own kind of natural clutter, with meteoroids and cosmic dust drifting through the void. But NASA's Orbital Debris Program Office notes that all that natural material amounts to just 1% of the mass we have added in a few short decades. Funny, isn't it? That we complain about the weight of our own trash while ignoring the invisible tonnage we've hung above our heads. Each day, roughly 300 to 400 tons of micrometeorite dust falls to Earth from that natural cycle, yet most of it is smaller than a grain of sand, a cosmic sprinkling we never notice. Meanwhile, our artificial debris falls in dramatic fireballs, and we still don't pause to think about it. We have this capacity to ignore what we cannot see, and orbit is the perfect blind spot. So we dump our satellites, our rocket stages, our lost tools, and we call it progress. The Earth and the sky are both suffering from the same disease, a refusal to look beyond the immediate horizon. We measure the filth on our streets, but we refuse to measure the wasteland we've created above, because that would mean admitting a mistake. The real issue isn't the metal circling us, but the mindset that put it there, and that's a lot harder to clean up. It started with a single unassuming beep and has spiraled into a silent storm circling above us. From the first metallic ball to a dead 8-ton giant and a constellation of thousands upon thousands of blinking eyes, we have turned the final frontier into a junkyard. A 2009 collision between two live satellites alone scattered more than 300 trackable fragments, and every Starlink launched is just a 5-year ticking clock until it too becomes debris. We are not just putting trash in orbit. Oxford researchers in 2022 calculated a 1 in 10 chance that someone will be struck by space debris in the next decade. Meanwhile, researchers at the University of British Columbia found that our collective exposure to that falling hazard has quadrupled in just 10 years, purely because we keep multiplying the threats. So the risk is no longer abstract. It is a question of when, not if, it lands on our doorstep. We cannot just look up in awe anymore. We have to look up with the knowledge of what we are doing. The machines we built to explore now drift as monument-sized warnings, and the only force capable of cleaning up this mess is the same one that created it. Every skyward glance is now a gamble, a quiet lottery we never asked to enter. So I will ask you again, and this time, I want you to really sit with it. Do you actually know what is hanging right above your head?